Hi, this is Mrs. Schaefer, and I wanted to go through the Chapter 5, Lesson 1 material with you. Please pause this video at any time if you need to go through and review anything. We are going to be continuing to talk about elements. We've been talking about atoms, and now we're going to be talking about elements. We're getting ready to go into discussing compounds and chemical reactions, so we want to make sure we have some ideas straight. Our focus for today's lesson is recognizing that an element is a substance that cannot be broken down by chemical means. We're going to look at a review sheet questions number 1 through 4. If at any time you are struggling with this, remember you can use the steps of progression to help you. Just use it as a checklist. Can you define an element and the atomic number and go through each one of these? And if you're not able to give yourself, yes, I can do that, go back through the lesson material to find that information and help you out. Remember that if you can answer our review sheet questions 1 through 4, then you are on your road to being able to master that material of recognizing that elements are a substance that cannot be broken down by chemical means. There is a review sheet 5.06 that you can find linked in to your material in the calendar and in the announcements and also in the course. All right, so for our question number 1, this is a review from chapter 1. So these snips below are there from other lessons from our chapter 1. So elements cannot be broken down into simpler substances. They're all one type of atom. So an element is composed of the same atom in them. We do have some substances that are fully made up of one type of atom, but even like our aluminum foil is only 98.5% aluminum. There are other elements in that, so that makes it like a molecule or a compound. So, but every element has its own unique properties and it can combine with other elements to form molecules or compounds. So there is a video in the lesson material that will help you determine about elements, mixtures, and compounds. So please pause this and then go watch that so that you can use that idea to help you. So in my picture here, I have a box right here on the left, and this substance, this is a representation or a drawing of the element R. And I know it's an element because all of the atoms are the same. So that means that this is the element R because each atom R is together in this representation of the sample size. My box on the right is a compound. We know that it's not all the same. So it's not an element because each of these shapes represents a different atom. And they're not all the same. So it can't be an element. It can be a compound or a mixture depending on how you're looking at it. A compound means that it's an atom, 2 or more of them joined together. So it may be 2 or more elements or different atoms that are not the same that are joined together. Like in here, a square and a circle. The chemical bond is represented by the 2 touching each other. So in between is representing the chemical bond. And compounds have a fixed ratio. Water always has the same chemical formula, which we'll talk about. So in this sample right here, we have a compound RSQ. So capital R, capital S, lowercase q. So that represents R for round and then square. Those are joined. That is a compound because of that chemical bond right there. We do know from our chapter 4 that, okay, protons determine the element. Protons determine the element. So the identity of each element is based on the number of protons in the nucleus. Each element has a unique symbol, and it is assigned to them in the periodic table based on the atomic number. So here's some samples of that where we can see helium has 2 protons. That's how it gets its atomic number. Its atomic number is 2. And that is how we'll find it in the periodic table, which we'll get to more in a little bit. The atomic number we learned last chapter is the number of protons plus the number of neutrons, but that does not give us enough information to identify the element. If we are saying, hey, what's something that has the atomic mass of 4? The answer is, I don't know. You have to tell me how many protons are there. So you need to have that. All right, so this idea, some of the things that we're learning were discovered by John Dalton, who was a chemist and a physicist in 1803. And one of the things that is part of our theory about atoms is that matter is made up of atoms. Remember at the beginning of the year, we talked about how matter is anything that takes up space and has mass. Well, now we can define that a little bit different. Matter is anything made up of atoms. Has an atom, it's matter. We know that atoms can't be destroyed or divided any further with chemical and physical means. At the time of, like in 1803, Mr. Dalton was just like, that's as small as you could go. But we learned last chapter that you can break down a nucleus. That's called nuclear change. We'll get to that in a second. Atoms that make up an element are identical to each other. So if I had an atom of, or I mean an element here, and I said this is pure gold, that means that every atom in it is a gold atom. Atoms have very unique chemical properties and weights based on that number of protons, and they can combine together to form other compounds. We also learned a little bit about fusion last chapter, that many of our elements are created by fusion in the star. Well, let's build on that. It says this third paragraph, so the first paragraph talks about how elements up to iron are created in a star because of fusion. What about those that are heavier than iron? Well, we need some more information, and that's right here in this third paragraph. Although fusion can not fuse anything denser than iron, when a star explodes as a supernova, the energy released is sufficient to fuse heavier elements such as gold, lead, and iron. And it goes on, and you can read that. So remember that denser elements are formed because of an exploding supernova. Okay, so we also, just to review the idea, we've been talking about chemical means. Let's talk about nuclear fission. Remember nuclear fission, that definition? It means that atoms are created. Atoms can be fused together or broken apart with the quarks. So when we have our definition, we need to make sure that we say that atoms can be broken down by nuclear means, but not by chemical means. Nuclear means yes, chemical means no. That's the difference between the idea of atoms. Can they be broken down? Yes, by nuclear means, not by chemical or physical means. All right, so we can go through, you can review this, make sure you know how to go through the material. If you're a late student, read through, make sure you're using your time well. If you need any assistance, please let me know. In this, there is an SAT practice that you can go through. It's just some help so that you can practice taking some questions, and it's going to guide you through those questions. In our CC session, we're going to be looking at the idea that substances cannot be broken down by chemical means. If it's broken down more, like by nuclear means, then it can't be an element. Elements mean that they're composed of atoms. We've talked about this idea where we have elements created by fusion in stars up until iron, and then after that it's an explosion that occurs. We know that elements can be broken down by nuclear means but not chemical means. We can distinguish one element from another based on their protons, which is their atomic number. In this case, how many protons are in the nucleus? Here is a snip of a periodic table for carbon. So this is its square that we'll talk more about the periodic table coming up. Where do we figure out which one's the atomic number? Where's the atomic mass? So it's that 6. The number of protons is its atomic number, which is 6. That is what we use to determine one element from another. Oxygen, we know, is an element. It's on this periodic table because it can't be broken down into a simpler substance. All of these other things are true. It is essential to life. It burns. It combines with hydrogen. But the thing that makes it an element is that it does not break down into a smaller stable substance. In this idea, we're going to be learning about chemical formulas where C represents carbon, O represents oxygen. Here's a picture also of it in the corner. We have carbon dioxide, meaning it has 1 carbon atom and 2 oxygen atoms. So overall, we've gone through a lot of material. Please make sure you have gone and completed your review sheet questions 1 through 4 for today. If you have any questions, please let me know. For tomorrow, you're going to want to go through before the Class Connect session, lesson 5.02, and take that practice quiz. There is tutoring if you need any more assistance. Have a great day, and we will see you tomorrow.